Welcome to this demonstration on the assignment for the Coursera course Human Factors in AI. I'm going to build on the project which I used in the previous module. So I'll just give a quick refresher. So the idea was basically in the mechanical system, it is important to know when the machine needs the maintenance. And it's for that, it will be good to know, right, in the what conditions machine might fail. So you can assume there is a plant where you have multiple machines, and machine is sending out some data along with the ambience data, atmospheric data, surrounding data, under which machine is running, and the idea is to predict whether the machine will fail or not. Now the problem is important because that is going to help you, in improving the productivity and the downtime of the machine. So going further, so a small refresher on the custodian process on business understanding. So the target user is actually factory supervisor. Problem statement again, provided the machine running in a specific condition and predict if it is going to fail or not. Now it will benefit stakeholders across the company, starting from operator to the person sitting at the top of the hierarchy, right? Because it is it will improve the productivity and monetary benefits, no downtime. I mean, reduction in downtime. Current state, so again, so either we have regular inspection of the machines or the action is taken post failure, and that leads to loss of time and productivity. Now success criteria is basically ready to detect prospect of failure beforehand. Factors identified will not change drastically in quick span is an assumption. Output matrix is basically how accurately system is identifying the case when machine is about to fail. And outcome metrics is basically your improved downtime of machine. Now identify factors like the key factors: atmospheric temperature, condition under which machine is running, that is important. Load on the machine, how much load machine is running, is processing, right? So that again is are the factors that are going to impact the performance of the machine or the load of the machine. Now, solution validation plan, basically we have set of features like air temperature, machine temperature, RPM, torque, tool wear. Target will be a boolean flag indicating if the machine will fail or not. It's a classification problem, so we'll predict the target. Key metric should be precision, basically on how well we are predicting when it will fail. So that is important here. Evaluation is again done on the performance of the model on the test data. Model interpretation is done to provide key factors which are impacting the machine maintenance. Trying out different hyperparameter combinations and evaluate the performance further to make the model more robust. Now I'll start on the task analysis. Along with that, how the UX user design will basically be of the system. So you have machine sensors, like the sensors which are available in the machine, and atmospheric sensor which are giving the data maybe at a particular period of time via some IoT device or something, right? Some sensor to a centralized hub, right? So data across this machine and atmospheric sensor is being sent to a data repository. So these are basically your features. And then you can also assume ground truth is also coming to the data repository. The model also got trained, so that we've already discussed. The idea here is how user is going to consume, right? So let's say a model is already deployed. So on the batch by batch, we may be deciding that every hour your inference should run, or every 6 hours the inference should run. So it will run the inference in batches, and once the inference result is obtained for the particular batch, we have a post inference engine or a service that is going to save the result in the data repository for future purpose. And if there is any possible case of failure, right, we will alert the supervisor. Now this could also be done in few more things can be added here. For example, we can define subsequent, like not just one batch, we can monitor, let's say 5 batch, and 5 batch, if let's say number of batches for which there was an alert, there was a possible case of failure. So let's say out of 5, let's say there are 3 cases, we found that there is a possible failure, we will alert the supervisor. So we can maintain some kind of thresholding on how we are deciding the alert, and supervisor then can take the action and give the feedback also to improve our overall system. Now another aspect is basically the monitor part. We have to monitor how my data is changing, right, or what kind of data my model is interacting with. So we have a monitor service that is going to, for the batch for which it got inferred, it will get the prediction, it will get the current batch, and will monitor feature, target, concept, and performance drift. And again, let's say out of let's say 5 batches, 3 of them have a drift, we will alert the data science team, which is our backend team, or the developer team to retrain the model or to look at why there is a drift or the reduction in model performance and all that. So that's a very high level view on how the system will look like and how my two roles, personas, basically supervisor and data science team, will act. Now task analysis, to just go and get detail. So these are the few questions that I have tried to answer. How the data will flow, data from the sensors will move to a central data repository that we have already seen. How the data will be utilized, model will infer on the data in batches. Batch data will be used to monitor the drift in data and performance. How user will interact with the system. So post inference, we can have a service which will alert the user if there are any possibilities of the machine failure. We can also put some threshold on the number of batches we should detect failure to have a confidence level in the alert. So this could be an additional information that can be sent to the supervisor or to the data science team, that what is the confidence level in the drift or what is the confidence level in the alert that this machine is about to fail, right? To make it more robust. How the data science team will help. So basically, if there is a drift, alert will be sent to the data science team to investigate and adjust a model via retraining if needed. So that will make sure that model is always up to date. Now AI specific considerations. So whenever we alert a supervisor or possible failure of machine, we can explain the features which are impacting that failure, and also like the probability of the failure, right? As I mentioned, it could be based on batches, it could be based on individual data points, like average probability across all data points or something like that. If there are uncertainty in the model, we should clearly inform the supervisor to take actions. Let's say there is any abnormal behavior, we should certainly inform that supervisor that this prediction might not be perfect or accurate, so that again, system should act as an augmented system for the user, right? So that is where we will handle the uncertainty in the model. Feedback from the supervisor will be taken to improve the overall system. Now ethical consideration, fairness. So one thing, as I mentioned initially, so you can assume there is a plant, and inside that there are multiple machines which are running. Now plant can also be located in a particular location, right? So fairness could be done based on the location of the plant, right? That is the only aspect which I see here currently. Accountability. So for any performance related issues, data science team will be accountable. We will have alert to notify them to retrain the model, so that model is also to date. Our system is created to help human in decision making, not replacing the humans in decision making. So notification will be sent to the domain experts, which in this case is a supervisor, right? And they can act based on the confidence level, other metadata which is shared along with the alert. So they can act accordingly. Transparency, alert will have the details about how the model is reaching the predictions, some explainability part. We will also provide the confidence level or probability of reaching the predictions. With feature importance, we can provide factors like improving a feature can reduce failure by what percent. So maybe let's say if the RPM is reduced by this percent, the possibility of the failure of the machine will reduce by a particular percent, right? So all those factors can also be sent to the user. Privacy conditions. So this I have kept as the last slide, because in this we are not collecting any personal information. So there is no data involved, which can violate any kind of privacy consideration. Along with that, the data is also used. Use is not related to any user. In case you want to keep an isolation, it could be access control on the data based on team. So that again is access on the data, but not the personal data, right? Like a data science team, within data science team, you can have like access control on who is accessing what, right? So yeah, with this I conclude the demo. So basically what we have discussed is a system which is going to help the user indicate that there is a possibility of a failure. The inference will be done in batches, right? And you will have monitor which is going to monitor how my data is changing, so that model can be up to date, and that will be taken care by the data science team, who is going to retain the model as per the monitor alert. So yeah, thank you.